Hello, Mr. Schwannekamp here. Today we are going to finish up this logarithm chapter. Lots of different things happening here today, but the main focus is our job is to try and solve this problem right here. All right, I always kind of like getting this lesson back to this. This problem right here, 2 to some power, is going to get me 7. That's a real simple question, but again, that's what the whole chapter is kind of around. 2 to some power is going to get me 7. I need to know that value. That's what we're working with today, and that's what we're going to try to solve. Nothing crazy. Definitely a calculator day. Make sure you got your calculator nearby. We're going to run through a couple topics kind of to start to make sure you understand some basics, and then we'll get into it. So without further ado, let's do it. So solving exponentials, that's what we're going to do. We're going to solve when x is in the exponent. So far we've done that, but every time we've done that so far, we've done change of base, and that doesn't work all of the time. Like 2 to some power gets you 7. All right, so before we get too deep, let's talk a couple things, and probably could have thrown this in anytime, but just make sure we know it. Common logarithms, just like this. So this drives me crazy, but let me go on a side note here. If you are using your iPhone to take a square root, it gives you that right there. It is a square root symbol, and they put a 2 in front as opposed to a cube root. Nowhere else have I ever seen the 2 up there. All right, we don't put a 2 with the square root because it's just implied that if you see a square root, there's a 2 there. Well, same thing is true with logs. If we see a log, we've done lots of base 2s and base 3s and base 4s. You can do a different base, but if you just see like log of x and there's not a base, it's because the base is the number 10. It's implied. Just like the square root, it's implied that there's a 2 right there. Same thing is true. So if you look at a calculator, you're going to see the word log. When you see the word log, it is not all logs. It is simply, go away. It is simply log with a base of 10. So just be aware, if you see log, it's got a base 10 there to set it up. The other thing we got to deal with is Euler's number, okay? You see the letter E. In math class, if you see the letter E, that is a number, okay? Just like pi, when you see pi, that is 3.14159. All right, if you see I is the square root of -1. E is a number. E is 2.71, and then I believe it's 8, and it keeps going from there. It's an irrational number, meaning it never adjusts to it. But just so you can see it, let's look in my calculator. So I'm going to go second, and then right here I got this E button, so I'm going to use that. Notice that it automatically deals with an exponent. When we deal with E, we are going to use an exponent. If I want to know what the number is, I'm going to do e to the first power. There's that number, 2.718281828, and it just kind of does some different things. That's fine. We don't need to get super crazy about it. All you really need to know, it's not like pi where you can memorize tons of decimals. 2.718 is plenty. Just know that it's a number. All right. With that being said, we are often going to see this one, a natural logarithm. If you see ln on your calculator, ln is what we use with log with a base of e, okay, more commonly presented as natural log of x, okay? So when you see ln, instead of nl, natural log, they use ln, but it's the natural log. When you see that, it means log with a base of e. Each one of these topics I could have gone pretty in depth into, but it's not really worth what we need to get done today. If you want to know more about natural logarithms and Euler's number, the letter E, it's some really cool stuff. Check out YouTube and Google it to find a little bit more information. But for today, we're going to leave it at that. So log of x is equal to 2. If I want to solve it, I don't like logs, so I want to get rid of a log. All right, well, in the past, we've had like log base 3. And if it said log base 3, we know how to get rid of a base of 3. We're going to raise both sides to have a base of 3. But if it's log of x, to get rid of the x, or to get rid of the log, we are going to use 10. Because remember, if you just see log, there's a base of 10. All right, so I'm going to raise both sides to 10 to that power. 10 and log base 10 are going to cancel. And then over here, it's 10 squared. Well, what's 10 squared? 10 squared is 100. Done. Number 2, natural log of e to the third is equal to x. Well, think about what this means. Natural log. Oh, natural log means log base e of e to the third is equal to x. Well, we know this. We know that log base e and e to a power, those two things are opposites of each other. Okay, they're inverses. So when you see that log and natural log of e, or natural log of e and e, they're going to cancel each other out. And so when you see this natural log of e, those are going to cancel, leaving you just the number 3 is equal to x. All right, if you wanted to say, oh, I want to get rid of natural log, well, what would you do? You'd raise both sides to e. And then what you'd have e to the third is equal to e to the x. Yep, x is equal to 3. So lots of different ways you could write that. Just know that they cancel. So e to the natural log of 4 is equal to x. E and natural log, oh, those two things are opposites. They're going to cancel. I'm left with 4 is equal to x. 6 and log base 6, those two things are opposites. They're going to cancel. So I'm going to be left with just 2x is equal to 18. They just cancel. I don't have to do anything special there. They're just going to cancel out. Divide by 2, divide by 2. Again, they all cancel because they are inverses of each other. X equals 9. All right, so just be aware how inverses work. Next thing we're going to do is change of base formula. And I used to think this was a little bit more important than it is now. You can do this on a graphing calculator, and I'll show you how to do that. But if I want to do log base 3 of 27, all right, we know what this answer would be. If we wanted to, we could say, all right, let's make that equal to x, because I'm trying to figure that out. To get rid of log base 3, we're going to raise both sides to have a base of 3. 3 to what power gets me 27? Oh, x is equal to 3. And that's great. You can do it that way, but it's not always going to be that easy. And so we need to use our calculator to do that. We do not use this button right here by itself. We can't just use log because that's a base of 10. And so what we're going to learn today is called the change of base formula. And you can see what they talked about right here. To do log base 3 of 7, you take the log of the number, so the log of the big number, divided by the log of the base. So log base 10 of 7 divided by log base 10 of 3. That's going to get me my right answer. All right, so for example, on this one, log base 3 of 27, I'm going to do it the other way. I'm going to take the log of the argument, so the log of 27, divided by the log of 3. And that allows us to rewrite the base in a different way. So log 27, close the parentheses, divided by log of 3. And if we did it right, we know what the answer is going to be. It should be 3. Yep, we got it. Okay, so that is how we're going to evaluate logs with different bases. If you've got a nice enough calculator, if you've got a graphing calculator, you can do that in another way as well. I'm going to hit the math button on my graphing calculator. And if I scroll down in this menu enough, there we go, log base, I'm going to go log base 3 of 27. Just depending on your calculator, you could do it that way as well. If I were to go to Desmos, if I was on Desmos and didn't have a graphing calculator, this is my favorite one, and you could download the app. It barely takes up any space on your phone. If I hit the functions button, go to miscellaneous, and there you have log, but then I have a log with a base. So log base 3, and then of 27. Yep, that gets me 3 as well. So however you want to do it, that's fine with me. Just make sure you can do it. So be aware that to find this number, you take the log of the number divided by log of the base. And sometimes that's easier than finding all those weird menus anyway. So if I want to do B, it's log of 18 divided by log of 2. Log of 18 divided by log of 2. And this method actually works whether we use log or natural log. If I take the natural log of 18 divided by the natural log of 2, still going to get me the same number. Doesn't really matter how you get there as long as you use those buttons. So 4.170. Last one, log of 5 divided by 6. So again, understand what we're saying. This is like, if I raise both sides to 6, let's say 5 is equal to 6 to the x power. 6 to what power is going to get me 5? Well, the only way they can do that is if x is less than 1. So if I wanted to type this into my calculator, I would do log of 5, log of the argument, divided by the log of the base. So log of 5 divided by log of 6. 0.898. And again, that should make some sense here because this number needs to be less than 1 in order to get me 5. That's change of base formula. Again, if you know how to use your calculator, it's not too bad. All right, so this brings us to this problem right here that we have dealt with over and over and over again. 2 to some power gets me 7. I know 2 squared gets me 4, and 2 cubed gets me 8. So it's got to be some number between 2 and 3, but what's that decimal going to be? All right, this is kind of silly, but how do we get the x out? Okay, I'd say it's stuck up in the tree because it's stuck up in my exponent. It's not 2x. Nothing drives me crazier than when a student says 2x is equal to 7. Oh, I divide by 2, divide by... No, that is garbage. That is not how you get the x out of the exponent. What is the opposite of an exponent? The opposite of an exponent is a log. So to get the x stuck out of the tree, you got to throw a log at it. Imagine you were going to play frisbee with your friends and you got a frisbee stuck in the tree. How would you get it down? You would throw something at it. And what are we going to throw? We're going to throw a log. So I'm going to throw a log at the left side. Whatever I do to the left side, I've got to do to the right side. And then understand why we can do that. I've got log base 2 and 2. Those two things are inverses. So what's going to happen when I take log base 2 and 2 and put them next to each other? They're going to cancel. Or in other words, if I have an exponent here with my log, remember we rewrote this thing. If you rewrite it, that x is going to just come down in front. It's just x equals log base 2 of 7. So now that we know how to use my calculator, we could say, oh, x is going to be equal to the log of the argument divided by the log of the base. Or in other words, log of 7 divided by log of 2. That is what 2 to what power gets me 7? 2 to the 0.807. If you don't believe me, let's try it. 2 to that power. I'm going to go up there and steal that answer. 2 to that power should get me 7. Boom. We answered that question that's been stuck on our minds for several days now. That got us the answer we're looking for. All right. So in other words, why do we throw logs? Why do we throw logs? They are the inverse of exponentials. And again, that if you only learn one thing in this entire chapter, I hope that's what you take from it. Okay, inverses, logs, and exponentials are inverses of each other. All right, so let's put this into practice. 3 to some power gets me 30. I want to get the x out of the exponent. What's the opposite in exponential? Log. So we are going to take a log with a base of 3 on both sides. Log base of 3 right there is going to cancel. Over here, I've got log base 3 of 30. And how do I type that in my calculator? Log of 30. I can't type that in. Log of 30 divided by log of 3. 3.096. And again, if I want to check that, 3 to this power, is that going to get me 30? Yeah, it should, because 3 to the third would get me 27. So a little bit bigger than that is going to get me 30. Letter B, same thing. Okay, we are going to get rid of this. That x plus 2, it's in my exponent, so I don't want to mess with it yet. The first thing I got to do is get rid of the exponential. So log base 4 and 4, those two things are going to cancel, leaving me with just x plus 2. Over here, I need to figure out what log base 4 of 15 is. So I'm going to take the log of 15 divided by the log of 4. So in my calculator, I'm going to take the log of 15 divided by the log of 4. That is not my answer because x plus 2 equals that. So what do I need to do? I'm going to subtract 2 from that answer, and it's going to get me my real answer, negative 0.047. That's what x is going to be here. We just keep going right along. Let's try another one. Letter C. 2 to the negative 5x is equal to 18. I've got an exponential. How do I get rid of it? Log. Log with a base of 2. Those two things cancel. Negative 5x is equal to the log of 18 divided by the log of 2. That's how I type that into my calculator. Log of 18 divided by log of 2. Hit enter. That is not my answer because negative 5x is equal to that. What else do I need to do? Well, I need to take that answer and divide it by negative 5. Negative 0.834. So we took log of 18 divided by log of 2 and then divided by negative 5. Moving right along. All right, this time we've got something else. So before I mess with the exponential, I'm going to deal with this negative 4 first. Because think about PEMDAS. Okay, when we do PEMDAS in reverse, we add or subtract first. I've got an add or subtract step. It's this negative 4. So I'm going to get rid of that first. So 10 to the x minus 3 is going to be equal to 17 plus 4, so 21. I do not have a multiply divide step. What I do have, though, is an exponential step. I've got this step. How do I get rid of an exponential? A log. Log base 10. Now, hopefully you recognize, hey, it's silly to do log base 10 because it is already log base 10. So if I want to do log base 10 of 21 over here, all I really need to do is log of 21 because it's already written as a base of 10. If you want to, you could do log of 21 divided by log of 10, but it's kind of silly because it's going to get you the same answer, 1.322. That's not my answer because I need to take that number and add 3 to it. I can add 3 without using my calculator, 4.322. That is going to be my answer on D. Ooh, I just got a bunch of these. All right, let's speed up this process here a little bit. So I'm going to go a little bit faster. 6 to the 2x minus 4. I'm adding 3. I'm going to take log base 6 to get rid of 6 to a power. That's going to cancel. In my calculator, I'm doing log base 6 of 3. So log of 3 divided by log of 6. I get that number right there. So I found out what this is. I still need to add 4 to that and then divide by 2. So I'm going to add 4 and then I'm going to divide by 2. Notice that I hit enter in between because I'm doing it step by step. My final answer is 2.307. It gets a little bit confusing here because I know I'm not writing down a number because it was that weird decimal number. And I don't really want to write down that weird decimal because otherwise I'm rounding and I'd rather just keep it in my calculator. But I found this, then I added 4, then I divided by 2. That got me my answer in the end. Let's do 2 more. Let's do F and then H. So this guy right here, I want to get rid of E to the x minus 4 equals 100. Well, I want to get rid of E. What is the opposite of E? Natural log, ln, log base E. And so if I do that, that's going to cancel. And in my calculator, I just need to type in the natural log of 100 because I got that button. That's already a log base E. So I get 4.605, but that's not what I want because I've got this minus 4. So I'm going to add 4 to that answer. So I'm going to take that plus 4. My real answer, 8.605. Boom. There's my answer on F. Last one, letter H. Start off by getting rid of this guy, so I'm going to subtract 5. I want to get rid of E. How do I get rid of E? Natural log. So in my calculator, I'm taking the natural log of 16. That's not what I want because I want to get rid of this 3, so I'm going to add 3. So I got that answer. I'm going to go plus 3. Hit enter. But that's not my answer either because then I need to divide by 2, divide by 2. Notice that I'm doing this. I'm hitting enter in between each step. Divided by 2, hit enter, 2.886. That is what X is going to be. Make sure you're taking that off piece by piece. Otherwise, you're not following order of operations. That's it. Exponentials. We're done with the chapter. A different chapter. It's a little bit weird at times, but it's some good stuff. And again, understand everything we're doing was to try to solve this simple question. And hopefully now you recognize that you know how to do it. If you got questions, ask me. Thanks, guys.